Hello, hello, hello. Hopefully this is working. Hmm. The stream latency is low, is set to low. Let's see. Okay, you're able to hear me as well. Right. Um, Let me set up my lead code first. Okay, as the title says, I'm going to solve CSES problems. But first, I need to complete the daily lead code problem first. So yeah, let's do that. Hmm. Okay, we have an easy problem. Nice. Count partitions with even some difference. Some difference. Okay. You're given an integer array nums of length n. A partition is defined as an index I, where I is between 0 and n minus 1. Okay. Split the Splitting the array into two non-empty subarrays such that left subarray contains indices 0 to I, right subarray contains indices I plus 1 to n minus 1. Okay. So these are inclusive, I believe. Return the number of partitions where the difference between the sum of the left and the right, okay, uh, subarrays is even. Okay. Okay. The first thought that comes to my mind is using a prefix array. But there is a technique that I had used in one of the problems that I had solved earlier, where if you just set if you just set left equal to 0 initially and right, this is the left subarray, this is the right subarray. If you set the right subarray's value equal to the total sum of the given array, then while moving from left to right, you can add the elements value in the left and subtract that same value into the right, basically dividing both the values into left and right subarrays, right? So if I'm on the zeroth in sorry, if I'm on the zeroth index, if I'm on the zeroth index, then we add the value of zeroth index, uh, array of 0 to left, and subtract the value of zeroth index from total from right, which is this minus array of 0. Oops. And we iterate over the entire array. Let me see the constraints. Constraints are pretty low as well. Hmm. Okay, so you can do a O of n square solution, but this solution is pretty optimal using O of n solution time complexity, which is pretty efficient. Oops. Okay, so in total equal to, or just right equal to 0. Initially, let's just assign the values. Int I equal to 0, I less than dot length I plus plus. Okay. So right plus equal to array of I. So basically we're summing up the entire entire array's value here. Okay. Uh right. Now this for loop is just to get the total value of the array. Okay. Now the main logic starts here. Hmm. Let's see. As we move on, we add the current index's value to left. We have now see and subtract the current index's value from the right. Now just check if if what do we have? It doesn't say anywhere that the numbers can be negative or positive. So we just take an absolute value of left minus right. What I mean by that is if right, we don't know if right is always going to be bigger or left is always going to be bigger, because there will be a case where right, the value of right will be bigger and left will be small. And as we move after certain iterations, after we move through a couple of elements from this array, the value in the left will be bigger from the value in the right. So we take a absolute value and check oh, and check if it's even or not. If it's even, we just need to increment the value of count. Oops, count plus plus. Count equal to 0. And then just return the value of count, right? Wow. Mm. Oh yes. Yes. Will iterate through till n minus 1, because the subarrays cannot be empty. Can here splitting the array into two non-empty subarrays, right? So the right subarray contains from the ith index to n minus 1th index. So it right subarray will contain a single element. So we cannot remove that. Okay, I get it. Hmm, okay, cool. Let's give a submit, and it got accepted. Nice. Cool. Okay, let's see. Okay, now let's start with solving CSES problems. I have no idea uh, how the website looks. I have never opened it. I'm going to open it for the first time. CSES problem set. Okay. So I just searched CSES problem set. Let's see. Hmm. Introductory problems. We have sorting and searching problems. We have DP problems. Okay. Uh, we have graph algorithms, range queries, tree algorithms, mathematics, oh, string algorithms, geometry, advanced techniques, sliding window problems, interactive problems, bitwise operation construction problems, advanced graph problems. Oh my god. Okay, counting problems, additional problems, one additional problems, two. Okay, so we have a lot of problems here. Wow. Let's log in first. I'm just trying to set up my log and register into my CSES account. Okay. Uh, log in. Okay, I have logged in to the CSES website. Let's see. Let's solve some problems. Weird algorithm. Okay, so we'll be starting with introductory problems, weird algorithm. Let's go. Um, Memory limit 5 okay, time limit 1 second. Consider an algorithm that takes as input a positive integer n. If n is even, the algorithm divides it by 2, and if n is odd, the algorithm multiplies it by 3. Okay, and adds 1. If it's odd, 3 into the number plus 1. If it's even, just divided by 2. The algorithm repeats this until n is 1. For example, uh, the sequence for n equal to 3 is as follows. Okay, divide by 2. This. The task is to simulate the execution of the algorithm for given value of n. Input this, print this. Okay. Okay, so I don't have a inbuilt IDE here. I have to select a file. Wow. Okay, result statistics. Hmm. So I have to set up a new uh, folder for this. I need to hide my screen again. Mama, um, new folder. CSES. I'm open folder. CSS probably set open. Okay. Now I need to create a GitHub repository for, for this. I need to create a GitHub repository for this, which I don't quite remember, but let's see. What- what repositories you have? New repository. You need to check something. Okay. Okay. I think this might leak at some information, so I should hide my screen again. Repository name CSES problem set description. Choose visibility. I want to keep it private. Add a readme no. Create repository. Okay. I have created an a GitHub repository. Let's see. Okay. Nice. Oh, I think I can share my screen now. Everything's good. Okay. Okay. Let's see. Let's create a new folder first. Oh, introductory problems. Introductory problems. Wait. Yeah. The first one is weird algorithms. Weird algorithms dot Java. Publics class. Oh wait. I need to first import. Oh no. Intro package. Introductory. What? I guess. Oh yeah. I guess I need to remove the space. Package. Yeah. Let's go. Public class. Public class. Where do I go to? Yes. Okay. Let's see. Okay. So am I sharing my screen? Yes, I am. Consider an algorithm. Okay. We have to take an integer n. If n is even, there are no test cases. So we directly take an input n, int n equal to sc dot next int, right? This. Mhm. Oh, I need to spanner sc equals to new spanner system dot in, and then we close sc dot close. Okay. So we have n. Hmm. What do we want to do? While n, as the problem says, repeat the process until repeat this until n is 1. Is not equal to 1, we repeat the process. What is it? Let's write some comments here first. Uh, Okay. What does the problem say? If n is even, what do we do? Divide n by 2. If n is odd, multiply by 3 and then add 1. That's it. Oh, the constraints are pretty high. So I believe it should be long because the because the number, because it is 10 to the power 6, integer can hold up to 10 to the power 8. And if we go and keep multiplying it by 3 into n plus 1, will reach at some point, will cross the limit of 10 to the power 9, and will reach the range of long. So it's better to initialize it with long. Okay. So if n and 1 equal to 0, then n divide equal to 2. Else, we know that this is a odd case. So n equal to 3 into n plus 1. Just put this in bracket to be safe for safe side. Then we just output 10. Oh no, what do you want to output? Data is in the exam. Fine. Print a line that contains all the values of n during the algorithm. Okay, so we print it here. That's it. Um, Tests. Do I have to download all the tests? What is this? How do I run these tests? 7. Do we have an extension for this for CSS problems like this? Extension for CSES problem set in VS Code. Problem set. There's regular. Oh, so we can use that. Oh, we can use this CPH helper. So I think I don't need this. I will just change this for as of now. We'll pass this question. Oh, let's go. Let's go. Just copy and paste. Oh, wait. But oh my god, this is a problem. I need to open the folder from here. Okay. I need to open the introductory problems folder, not this out of CSS problem set folder. I'll still copy this code. Hmm. File, open folder, CSES Introductory, and open. Perfect. So copy this, pass this question, Java, great. What if I run this test case? Yes. Okay, this should work. After trash. Hmm. Okay. The algorithm, for example, the sequence is this. Your task is mm, output should look like this. Okay, so we need spaces between the numbers. Right. What? We have 10. Uh, and is called the algorithm multiplies 3. Hmm. Okay, so we also need to print the initial state as well. Everything else looks fine. Cool. Submit. Oh wow. Oh, I need to invalid Java source name. What is this? Why do I see this? Invalid Java source name. What do you mean by that? Choose file. This. It's Java. Submit. Why do I see this after submitting my Java code file on CSES problem set? Public class. This contain the level engineer matching the following. This was okay. Okay. I'll just copy and paste the logic here. But try public class is PSVM. paste the logic here. That's it. I oh it yeah, scanner, right? That's what I was worried about. Java dot util dot all. Okay, why not? What did I do? Fast. Choose file. This submit. Do request object was more. Okay, good. Good. No, Oh, let's check our paper. Okay, and we see a folder named Introductory Problems, and in it we have our file. Okay, so I need to do that. This is a long, lengthy way of submitting, but anyways, we have to do it. Ah, okay, next problem. Missing numbers. Uh, you are given all numbers between 1 to 10 except 1. E- Anyway, your task is to find the missing number. Okay. You're given all numbers between. So we have numbers from 1 to a given number n. We need to find a missing number. The constraints are also not that high, so we can perform a O of n time complexity solution, right? The first input line contains an integer n. The second line contains n minus 1 numbers. Each number is distinct and between 1 and n inclusive. Okay. Now, my question is that I am assuming this that the numbers won't repeat itself. Can the numbers repeat itself? We don't know. Hmm. All numbers except one. Oh, okay. So the numbers won't repeat itself because we have all the numbers except one, right? So to satisfy this condition, the all the numbers will be distinct except and one number will be missing. We need to figure out what that number is. Now, they will not give uh, us this. They will not give us the input numbers in sequence. So we can sort the array and then loop over it. So the time complexity will be n log n for sorting and then plus n. Why? Because we need to iterate over the loop and find the missing number. But I'm trying to think, is there a better way of solving this problem rather than just Mm. No, right? I think we just sort it and then loop over the uh, elements in the array. Need to pass the question. Yeah. Hmm. We have, do we have number of test cases? No, we don't. So we have int n equal to sc dot next int. Then we have a array of size n minus 1. Am I sharing my screen? Yes, I am. of size n minus 1. Now we loop through the numbers int I equal to 0. Or, okay, oh no, no, no. We loop through the numbers at n minus 1. Oh, now, in each index, we just take the input and store it in the array. Now, just sort the array. Is it array dot sort and arr? This will sort the array in ascending order. Now, we just loop again minus 1 minus this and check hmm, and check if array of I, if it's not equal to I plus 1, then we cannot return, right? We need to print the missing number I plus 1, 0th index. Why? Because see, we have indexing from oh, no. We have indexes from 0, 1, 2, 3, 4. We should have the number 1, 2, 3, 4, 5. What does this mean? That on the second index, we'll have the number I plus 1. So we print, if we don't find the array's element, and the index number plus 1 is not same, then we just print out I plus 1 and then break through the loop. Oh, yes, that's it. Let's see, let's run. This works. We and I should not close this file, main file. Okay. Cool. Now we just hopefully this works right. Submit, choose file, main, dot. So what we got a TLE. I guess why can we not sort? Which test is good? Oh, it is guaranteed that a number will be missing, right? So if we have 1 and 2 in the input, how is the correct output 2? Oh no, wait. The length is okay. Then so one. Hmm. We never check the last index here, right? Because we loop through n minus 1. In this example, 1, the index is 0. We never check this index. Hmm. So we need to loop over till n. That's one thing. Hmm. But if it ever reaches n, else if um, we just need to check if I equal to n or n minus 1, basically. Wait. Yeah. Uh, hmm. So, I'm if I equal to n minus 1, if it ever reaches n minus 1, just print I plus 1 because we have checked all the other numbers, till up till n minus 1, we have checked all the numbers, and if they are at the correct indices, if 0, if 1 is at the 0th index, it means that it is at the correct index, right? So, if it ever reaches n minus 1, we just simply print I plus 1 and then just break. That's it. Um, see, it is cases. 1. Is oh yeah, this should, yeah, this should work. Yes. And let's see this test case as well. Is this check? Oh my god. Yeah. Copy, copy, but copy. This gave a TND. See why. Okay, what is expected? Correct output should be this. Yeah. Yeah, so this is correct. It's passing. I make the changes here. It's okay. Let's submit again. Choose by main. What? Why is this giving a TLA? Okay. Where we have memory limit 512. We have time limit as 1 second. So it should handle this, right? 2 into 10 power 5. A time complexity should be, I mean, O of n log n plus n. I'm timing out because of slow input output. So I want to scanner is too slow on CSES for large inputs combined with sorting. Your RAS. Oh, hmm. Hmm. Okay, I understand this. But let's see why is scanner slow. Okay, basically what they're trying to say is that we need to find the missing number, right? So what if we just XOR the value up till n, up to n? So XOR equal to this. Then what we can do is we have the XOR value. Then we start taking the input. We know that 1 XOR 1 equal to 0 or n XOR n equal to 0. If any two numbers are same, the output will be 0. So, while taking the input, while taking the input, we just XOR it with our XOR. This will give us the remaining or the missing number. Hmm. And also the time complexity will be just O of n. Space complexity will be 1. Big O of 1. Okay. Ta-ta-ta. So we don't need to sort. We don't even need a array. We just need a variable store equal to 0. It is 2 power 10 power 5. So we are good with int for int I equal to 0, I less than n, I plus plus, XOR equal to I. Now, while taking input int I equal to 0, I less than n minus 1, I plus plus, XOR of this sc dot next int. Now we just print the value of XOR. We should be good. Wow. We received 0. Zeros or any number should be that number. So we start with 1, then till n. We hmm, no 1. We start from 1 and go till n minus 1. Okay. Here we are just taking the input. But why did I write 1 and here n minus 1? Just to be intuitive. Just so that it is more readable basically. Okay. We should be good. It did pass. Let's see. So well, this one pass. This is I'm talking about main. Around 200,000, which is 2 lakh. Let's see if this gives us a KD or not, because like GPT thinks it scanner is too slow, but I want to see it for myself. Let's see. Yes, it got accepted. So the problem was not scanner, rather it was the time complexity, which was I thought it should have passed uh all the test cases, but it didn't. And log n plus n. What's the value here? Let's see. 2 into, oh, this is log base 2, right? Calculate the value for 2 into 10 power 5. 3.7 million. 1 million is 10 lakh. And 10 power 812 3 4 by 6 7 8. Okay, so 1 2 3 4 5 6 7 8. This should be the idle limit, right? This is the limit for number of operations that we can perform, right? So why did this not pass? No, even after using scanner, for like, the solution got accepted. Okay. Okay. Add missing number. Okay. Oh, wait, okay. It's 12:06. What is this time for? Oh, repetitions. I need to plug in my charger because the battery is at 13%. I will be back in 2 minutes. Okay. Hmm. I just wanted to check something. Yes, a minute. Um, Okay, let's see. Uh, you're given a DNA sequence, a string consisting of characters A, C, G, and T. Your task is to find the longest repetition in the sequence. This is a maximum length substring containing only one type of characters. Character. Okay. The only output line contains a string of n characters. Print the only contain string. Okay. Print one integer, the length of the longest repetition. Okay. So we have A, C, G, and T. What I'm thinking is we can create an array of length 4 for okay, let me just write it down. Okay. Okay. We first create an array of length 4. Zeroth index will have A, or do I C, G, and T. First index will have this. Second index, third index. Second index, this is the third index, right? Now we just iterate over hmm, we just iterate over the string. Once we find do we create an array or a hash set? I think we should create a hash map. We create a hash map. Hash create a hash map. Okay. So basically this okay. So now A will have the frequency of A, we have C. C will contain the frequency of C, that is the max frequency. max frequency to this will contain the max frequency of C and so on. We just iterate over the string once we find a different character, we just check the frequency of current character, and then we just check the frequency of current character and the max frequency of that character. Once this is no, after this we initialize what is this? What is this character? The initialized count equal to 1. Okay. Yes. Okay. So this can be 1 as well. Okay. So if n, wait, I need to first take the input, right? Scanner system dot in, see dot this, intent equal to sc dot next thing. If n equal to 1, just print 1. Yeah, we print 1 and then return. Then return. If n is not equal to return 1, return 0. This is void, so return should void. This is see, do. Okay. If n is not equal to 1, then what do? We create a hash map, store the character, and this will be integer, which is the frequency. So frequency, new hash map, this. Okay. Now frequency dot put, uh we have the character A whose frequency is 0. Boom, boom, boom. Just initializing this C, then we have G, and then we have T. The initial value will be obviously 0. Now, oh wait, this is string. This will be next if int n equal to s. Yeah. This will be is, yeah, or in I, or should I just say in I equal to 0? Let's do this. I less than n, I plus s char ch equal to s dot char at this index. Now, we start. Just keep checking the previous element. If, or should we check the next element? Because when we reach the last index, we need to know whether or not it is in the continuing subarray or or not, right? So, wait, we don't even need a hash map. We just need to this is the maximum length, only one type of character. Okay, we just increment the count. Okay, okay, okay. Okay. We don't need this. I'm complicating these things. This thing. Okay. If if ch ch if ch equal to ch next count plus int count equal to 0, else if this character is not equal to the next character, now we check count equal to, oh, no, count, and then we need best equal to 0. Then we check best equal to math.max of best and count. Count starts from 1, right? And then now here we reset count value to 1 again. Now we print best, the value of best, and that's it. Because we just need the maximum length, right? This should work. CH. Well, is this the reason why it is failing? We cannot equate it like this or something like that. Oh, wow. Then again, that's equal to math.max of. For example, if all the characters, why did I do this, right? If all the characters in the string are same, then we will never reach the else condition. That is why we check here once again. Also, after reaching the end of the string, after reaching the end of the string, we never compare it with the best, right? We never compare it with the best. Yeah, we never. So at the end, it's better to compare separately. We do not need a hash map. Let's go. Wow. Why? Oh my god. N minus one. Of course. Cool. I think this will pass. This should pass. Nice. Okay. The number is pretty high. So we'll use long often solution should pass here. But I need to add this time complexity. What big O of n space complexity big O of 1 bit add repetition git commit. Ooh, my bad. Shh, let's delete this. Increasing array. You're given an array. Just a minute. Okay. You're given an array of n integers. You want to modify. Wait, am I sharing my screen? Yes, I am. You want to modify the array so that it is increasing. That is, every element is at least as large as the previous element. Is at least as large as the previous element. On each move, you may increase the value of any element by 1. What is the minimum number of moves required? The first n The second line contains n integers. The content is like the minimum number of. Okay. We want to modify the array so that it is increasing. Okay. Hmm. Okay, this is a easy problem, but let's see. Okay, first let me see if I am sharing the screen and my live is good or not. It looks like my live is good. This, yeah, char ch equal to start. Uh, okay, we just increment the count. Okay. Okay. We don't need this thing. Equal to ch next count plus plus. So else, if this character is not equal to the next character, now we check count equal to. Okay. I think I will speed run this problem. Let's see. Mm, Okay. What we want to find and what we want as the result is basically we want an increasing array, right? So we just check the difference between the two numbers and make it equal because here it says that every element is at least as large as the previous element. So if the next element is smaller than the current element, we just get the difference between those two numbers, right? And basically making it equal. If the current element is less than the next element, then we just move on. It's that easy. Okay, let's do it. Yes. Mm, Public as that is equal to system dot in c dot close. Oh, how about doing it int? We have an integer in sc dot next int array equal to declare it declare the size of the array equal to n. Then just take the input. Hmm. Yes. Just take the input array of I equal to a string. Okay, now just loop over the array plus wait. This should be long. This and this should be long. Yes. Yep. Because the values here go up to 10 power 9, right? And operations, just name it op equal to 0. If n minus 1 if array of I is less, no, is greater than array of I plus 1, we perform certain operations. What is the operation? Uh, we'll just subtract the value of an array of I, wait, int def equal to array of I minus array of I plus 1. Why is this a bit long? Of course, right? So just keep it long. I don't think it will, it can go up to, the value can be long. Operation number of operations, yes. Okay, so this is the difference, right? What do we want to do? We just add the difference in our operation, that is number of operations we need. You want to modify the array so that it is increasing. You may increase the value of any element by 1. Okay, right? So we increment the number of operations by the difference between those two numbers and then add the value, or basically the difference, in the next element, right? So that it becomes equal. Now we just simply print what are the number of operations and we should be good. Yes. Oh my god. Ah, yes. Cool. Submit this file. Cool. Permutations. Okay. A permutation of integers 1 2 till n is called beautiful if there are no adjacent elements whose difference is 1. Okay. And okay. Given n, construct a beautiful permutation if such a permutation exists. Okay. Print a beautiful permutation of integers this if there are several solutions. You may print any of them. If there are no solutions, print no. Print no solution. Okay. Hmm. This can be up to 10 power 6. What I am thinking is that this is like a math problem, right? What do I mean by that? That is, for given value of n, we need to find a logic such that, uh, it, I believe it will be a O of 1 logic where we would, know that, whether or not it is possible to find the different permutation, that is a beautiful permutation, or we cannot find it, right? Let's see. Hmm. Now I need to turn on the disk view, start Okay. Mhm. Okay. Let's see. Wait. Can you all see this clearly? Smash. Mm, hopefully, you all can see this. Hmm, right. So, what is the question? It says that we are given an integer n. We need to find whether or not the adjacent numbers values is same. The difference between adjacent values numbers should not be equal to 1. Can we construct a number like that? So, for example, if we have an odd number, let's say 0, 1, 2, 3, 4. I have numbered this from 0 based indexing, uh, which means that the total length of this is 5, right? Hmm. So if I take 1 here, I place 5 here, I place 2 here, I place 4 here, and I have to place 3 here. So this won't work. Hmm. What can I do now? Hmm. Okay. So this doesn't work. So I want this 0, 1, 2, 3, 4. I place 1 here. I place 3 here. I place 2 here. Oh, but this is okay. Hmm. But here the adjacent values becomes, see. But for 5, what they have done is 4, 2, 5, 3, 1. Hmm. They have is at 4, 2, 5, 3, 1. What can we do is the adjacent value should not be equal to 1. So 1 comma 3. Hmm. What can we do here? Okay, I see a pattern here that the difference is 2, right? So can we group the numbers such that their difference is more than 2? That is, the difference should be 2 equal to 2. Right, right, okay. Kind of, okay, okay, I get it. Uh, See, the difference here is 2. The difference here is 2. And because we have odd numbers, we can place a larger number between these two so that it will never be, so that it will become a beautiful string. Permutation. What happens if we have a even number? Let's say 1, 2, 3, 4. 0, 1, 2, 3. So if I place 1 here, I have to place 3 here. If I place 3 here, then I can place 4 here and then I can place 2 here. So there is a way. I just place 4 and 2 here. Okay, so if I start from 1, I increase the number, and if I start from the end, I start from 2 and I add plus 2, I go behind here, right? I add plus 2. Now, what we have to check is whether or not this, oh, this is not a beautiful permutation, whether or not this and this index, the numbers are equal, that sorry, the difference between these two numbers is 1 or not. In this case it is, so we print no solution. hmm. If a number is odd, and if any number is odd and it is greater than 3, that is if it is equal to 5 or more, the it will create a beautiful string, a beautiful permutation. Let's see another example. 1, 2, 3, 4, 5, 6, 7. Okay, we have 7 integers: 0, 1, 2, 3, 4, 5, 6. Right? Huh. What we can do here is I add 1 here, I add 3 here, I add I add 5 here, I add 7 here. I go up to the limit, up to n, right? Now I stop here. Now what we do is start from, wait, if I start from 2 here, I will add 4 here. Then I'll add a a 6 here. Hmm. But these two will create problem. If it is odd, if the numbers are odd, we can do print it like this: 2, 4, and 6. Right? Just print it in increasing order. It won't matter. Yeah, for 3012, if I print 1 here, I have to print 3 here. But then this will create a problem. I have to start with 2 here. This will create a problem. If I write 2 here or 4 here, it doesn't matter. Hmm. So for any odd number which is greater than 3, we print the sequence. If it's equal to 3, we just say no, no solution. Okay, so we know what to do if we have a odd case. What if we have a even case? Let's see. 1, 2, 3, 4. 0, 1, 2, 3. Let's start with two elements first. 0, 1. Just a minute. Yeah, right. Okay. What if I have two elements? Hmm, okay. Uh, what if you have two elements? We write 1 here, we write 2 here. So it is not a valid or a beautiful permutation. Hmm. What if we have a single element? We write 1 here, but we don't have any neighboring numbers. We don't have any neighboring numbers. So what should we do? So it is a valid case, right? Hmm. Yep, this should be a valid case. Let's see though. Hmm. Let's see for if n is 4, if n is 4, how can we solve the problem? If n is 4, I will write 1 here. I will write 3 here. I'll write, I cannot write 2 or 4 here. What if I write 4 here? I can write 2 here and then a 3 here. Hmm. Let's see for 6. 1, 2, 3, 5. If I write 1 here, I'll write, sorry, 6 here. I'll write 2 here. I'll write 5 here. But this will, I'll write 3 here and then I'll write a 4 which will cause problem. I can also write this as 1, 3, hmm. If I write a number, we cannot take its adjacent numbers. So what I'll do is take 4 here. Oh, sorry, take 5 here. If I take 5 here, I'll go out of bounds. If I write a 7 here, so I'll start from 2. I'll start from 2, we'll write 4, and then we'll write a 6. But this logic didn't work here, because if I write 3, if I write uh hmm, if I write 2 or 4, anyways it's going to fail. So I need to write the earlier combination there. Is there a better way or a solution to the, uh, find the solution for this problem? I think I need to oh, check. Wait a minute. I think I need to check CSES problem. Like a YouTube video. I know that. What is his name? Ericto has uploaded a video or live streamed solving CSES problems. CSES problem Ericto. He solved these problems. He solved these problems 3 months ago. Sorry, 4 months ago. So let's see.
A permutation is called beautiful if there are no adjacent elements whose difference is 1. Given n constructive problem usually, and there's often not.
Oh wait, I need to move myself. Move it up here.
One correct solution. There are many. Whatever you come up with, that it's correct. So like if I have numbers 1, 2, 3, 4, 5, 6, 7, 8, how can I arrange them so that two consecutive values cannot have a difference of 1? I don't know, I can go 1, 8, 2, 7, 3, 6, 4, 5. That doesn't work. 5 and 4 are consecutive values. Then let's move 5 to the front. Well, that works. So maybe that's my solution. First, last, second, last. Maybe that's not very good. 1 and 2 and minus 1, 3 and minus 2, and so on. And then last two elements will have a difference of 1. So move the last element to the beginning. That's something. It will not work for very small n, like n equals 2 will not work because elements 1 and 2, no matter how you reorder them, they will collide. I'm not 100% sure about correctness of what I came up with, but it's something. And I think I will code it to see if it works. I remember another solution where it goes like this: 1, 3, 5, 7, and so on. So all the odd values, and then all the even values: 2, 4, 6, 8, and so on.
We thought of the solution.
I think I will code.
we thought of the solution, but it failed for n which is small, right? So I need to find a better way to solve
both versions.
this problem.
I'm also curious if the first one is correct. For some values of n, we need to print no solution, but I'm going to take care of that at the end. To output it yet, because for some, let me create, should be no solution. But here, iterate odd values, starting from 1 up to n, increase by 2. So this thing. In Python, that would be range from 1 to n with increase of 2. This is how you can iterate odd values. A pushback I, then do the same for even. A pushback I. So here I started from 2, and it goes 2, 4, 6, and so on. And now, I don't know, we can check if I didn't make a mistake, if I don't have 2 consecutive values with a difference of 1. I will make a mistake on purpose for a moment. If difference between a of I and a of I plus 1 is equal 1, this is bad. No solution. At least my solution doesn't work. And stop. And otherwise, for every element inside of my array, output it. And new line at the end. Now, yeah, I made a mistake here. I already told you in the previous problem that when you do I plus 1 or I minus 1, you need to be careful for out-of-bounds errors. If you want to compare 2 consecutive elements, you don't need to compare the last element with something after it. That doesn't make sense because there is no element later. You want to stop one element earlier. Now I think that this is a correct solution. We'll see. 0, 5 permutations, 5. 1, 3, 5, 2, 4 works. 8. 1, 3, 5, 7, 2, 4, 6, 8 works. 1, 1. Makes sense. 2, no solution. Makes sense. 3, no solution. Makes sense. 4, no solution. Now, is that true? 1, 2, 3, 4. 1, 3, 2, 4. 3,
Yeah,
1,
it will be no solution.
4, 2. What about that? That's a counter example. My solution is incorrect. For n equal to 4, my exact logic doesn't work, but I see a sequence that works. I believe that my program for bigger n's will find the answer. So I'm going to just fix this n equal to 4. I'm going to say if n equals 4, a becomes, what was that? 4, 1, 3, 2, no. 1, 3, 1, 4, 2. Okay. So it's still odd values and even, just in different order. If I now run it, 4, I have the solution. 3, no solution. 5, solution. Okay, submit. Why are you using int size instead of size? Because of the types. Theoretically, if something is empty and you do this, it's a very strange thing. So I will answer this question. Consider this. You have an empty vector and you want to, for every index, except for the last one, let's say output this index. This program should do nothing. My compiler warns me that something is wrong here. But what we will actually see, if I run this, is we get infinite loop. We have a lot of values. This is why I cast to int. That's a C++ specific thing. So what happened here is v.size is 0, but it's unsigned 0. And if you subtract 1, the value of this highlighted part is 2 at power 32 minus 1. If you cast size to int, then it will work because this is 0 that can become negative later if you subtract, and now this is -1. So if I run, nothing is printed by this loop.
Okay, so you just fix the value, like just hardcode at the value for n equal to 4. Okay, we came up with the solution, the exact same solution, but I got confused. Um, but I got confused because it was failing for lower value solutions, lower n value solutions. Okay, let's see. Let's write the code. Mhm. You just have a singular integer. Hash. Mhm. Okay, I try this presence overlay. What's this? Hmm. Just see the code behind me. Intent equal to SC. Okay. Why do you see this? Yeah. What do we need? Hmm. Okay. We just construct an array. Int size n. How does this look? It should not go that. Oh, let's turn it on. Oh, hmm. Okay. For int I equal to 0, I less than n, I plus equals 2. Hmm. This is hmm, I plus 1. And the odd numbers first. So I equal to I plus 1. Then now we just simply print out the values. It should work, right? Let's see. Wow. Oh, wait. Doing this. Uh-huh. Yeah, but uh, we have received output is 1, 2, 1 from 0. Okay. We start from 1. This we start from 2 here and just insert all the even numbers. Hmm. Okay. We run this loop once. If array of I is not equal to, sorry, if math.ps minus array of I plus 1 is not equal to 1. If this is the case, sorry, is equal to 1, then just print no solution. Else, I can use what? Oh, wait, my God. Equal to 1. Now, hmm, and we just return. If we have a solution, we just simply print it out. Array of AII. This is this. And we should be good. Obviously, check up to n minus 1. This should work. What? This pass? Why am I seeing? array of I minus one is full. Oh wait, oh wait, oh wait. Has been it's right there. Oh, okay. Hmm. I'm using an array. This makes sense. I can use an array list as well. Just add I, just simply add I. Four comma one comma three comma two. How can I insert the value like this? How to insert values like this in array list? Let's see. Array dot get I. Then how can we initialize arrays as list? Arrays dot as list. Oof. Or you can just, oh no, arrays dot as list is better. Arrays dot as list. You have 4 comma 0 comma 1 comma 3 comma 2. Four, two, oh wait, I should be expecting 1, 3, 5. Oh, this should be, oh, no, this should be 1, 3, 5, 2, 4. This should be this. No, this is also equal. But yeah, it will perform anyways. Makes sense. In this case, if I could check for 3, execution. I want to run this. How? Silly. Come on. Play. Yeah. on Java C. But I want only Java. What if? Wait, I can literally. Oh my god, what am I doing? No, 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 no. Run Java. Come on now. Code is already running. Oh, why did it take so much time? Code. Okay, so this is working. Okay, let's see. Let's submit. Oh, we got it TNE. Hmm. 42413. What did I write? Oh my god. 2413. That was a mistake. The number is 10 power 6. This entire loop means that I'm running it once for 10 power 6, right? So this entire thing is often. Then we check if this is same or not. This is O of n. Then this is O of n. So basically, our time complexity is O of 3n. So it's not 3n. So why is it not passing? Well, I copy this and the expected output. Yeah, 344 milliseconds, 84 milliseconds. Huh. Okay, my Java solution. By going this solution, solution. Okay, on CSES. Good. Get the problem. Wait a minute. Mm, This is so dumb. Slow memory and automation. What so often? What is this? Buffer reader BR equal to new buffer reader, new input stream reader. This is so simple. Buffer reader BR equal to new buffer reader input. What is this? New input stream reader system dot in BR Wow. Integer dot parseInt. No shot. Why is this so lengthy? Integer dot parseInt. VR dot readline. Is this fine? Okay. Uh, this is so stupid. Hmm. So we cannot use an array list. Why? Because CSES doesn't like Java. Um, do we not close this VR reader? Whatever. Why is it throwing this line is throwing error? Okay. N equal to 2, or if n equal to 3, just print no solution. Otherwise, print I equal to, and we also return from here. Otherwise, string builder is b equal to new string builder I equal to 2, I less than equal to n, I plus equal to 2, just just append this character plus space. Similarly, do this for even. Sorry, for odd. Now we just output this as b dot to string and done. Oh, what is this? Read line vr dot read line and then the bracket. It is a function, right? It is a function. What is there here? Oh my god. Throws exception. You have to write all of this. Throws exception. So 2, 4, 1, 3. Yeah, cool. What is the time complexity for this? O of n. Hmm. What is the space complexity? what is the space complexity for this code? So it is often. Let's go. Wow. A number spiral is an infinite grid whose upper left square has number 1. Here are the first 5 layers of the spiral. Your task is to find out the number in row Y and column X. Okay. Okay, so at index 2, comma 3, value is this, 1, comma 1. Mhm. Okay, so we have to create a matrix of size n cross n, and what is known as an infinite grid of minus 1. What is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I used to find out the number in row. The first input line contains an integer t, the number of test cases. Oh, okay. After this, there are t lines, each containing integers y and x. Y and x. So in row y and column x. Okay. For each test, print the number of print the number in the row y and column x. What is this problem?
Yeah, so I agree, by the way, that here, instead of this if, I could do odd decreasing, then even decreasing, or something like that, but I came up with something. I checked that it doesn't work for 4, which was tricky. That was easy to miss. And I just fixed that single case. But I'm not sure. Let's p 1, 2, 3, 4, 5. Square has number. Number spiral is an infinite grid whose upper left square has number 1. Here are the first 5 layers of the spiral. 1, 2, 3, 4, 5, and so on. Like that. Your task is to find out the number in row y and column x. And for the first time, we need to be careful about the constraints. because there are some values up to 1 billion here, and actually that matters. Also, we have multiple test cases. Let me comment about this. If you're experienced competitor, this will be boring for you, but this stream and its recording is for people who are starting with CSES or competitive programming. Very often, in a problem, you will see this line or similar. First input line contains an integer t, the number of tests, or the number of test cases. So far, our program, after running it, it would read the value n, and then some kind of array. And we want our program to run a lot of arrays. There are a few, 1,000 possible distance. It is often faster to do this format of testing. Additionally, sometimes we need to distinguish the time complexity, and this is a better way to do it, whatever. Now, when you see something like that, what usually you want to do is read the value of n, the number of test cases, and then repeat t times. Here you solve a single test case. I don't want to put all my program inside of the for loop, because it's then harder to sometimes see mistakes, harder to do break. This is a separate piece of logic, so I will make a function with a test case.
Just a minute, I need to add this to my GitHub repository. Git add git connect push. Okay.
And I think very often from this case is we have y and x, row and column. I hate the xy, using xy names of coordinates in programming because they are often confusing. In math, x goes to the right, y goes up. Simple drawing. So this cell, a point is x comma y. But what you have in programming, in computers, so multi-dimensional arrays, also just pixels in monitor or pixels in paint, is that things are displayed row by row. So you have row, displayed row by row. So you have row, and you have column. And a cell is usually denoted as a pair row comma column, which is different order from what was here. Row, the y coordinate goes first. Because of that, I almost never, use the coordinates x and y in programming because it's confusing that the cell is y comma x. And in your code, you often need to type a of y x. It's easy to make a mistake. If you're used to math coordinates, then you will type xy. And that's a mistake. So instead, you will see me almost always use names of row column of r or r comma c. Row column, read row column. Now, this was unrelated to solving the problem. We need to now solve the problem. Given the row and column huge, up to 1 billion, we need to find what value it is in this huge infinite grid. Let's try to do it. Maybe I will copy this. This is the spiral problem. Such a spiral of size n by n. I'm sure easier task, but still not. No, an easier task, but still not trivial, would be to output such a spiral of size n by n. I'm sure you can find such a task online with a solution. But what we need to do is, quickly we need to be able to say, what would be a value in this cell? So 1, 2, 3, 4, 5, 6. What if we are given a cell at row number 6, column number 4? We need to know what is this value without iterating the grid, because coordinates are up to 1 billion, and you cannot do 1 billion operations within a second. Can you explain yx thing again? It doesn't matter that much. Long story short, I prefer to use names row and column in programming, not X and Y. Anurag, I'm doing CSES problems. Don't repeat the question. Well, this spiral has numbers from 17 to 25 here, and then from here to there, it will have numbers from 26 to something. Now, you can use math or observation or fact that this is a square to observe what are values used in every next layer. This is the first layer, this is second layer, third layer, and so on. Every next layer will expand the square, and the size of a square is n squared. So the value here is 25, it's 5 squared. The value here is 16, 4 squared. Value here, 9 is 3 squared. So always every next layer goes up to n squared. Generally, nth layer goes up to n squared. So n plus first layer, here it goes up to n plus 1 squared. And because the previous layer went up to this, it means that n plus first layer goes from n squared plus 1 to this. For example, 6th layer
Okay, 6 layer will be 25 plus 1 is 26. Oh, that is a good observation. So row 1, for row, if we are at 1, it will be 1. But then for 2, it will be its square. For 3, which is odd, it will be 2 square plus 1, which is 5. Then for 4, we have 16. Then for 5, which is an odd number, it will be 4 square, which is 16, plus 1, which is 17. Okay, this makes sense. But if we go another layer, inside this outer layer, we have a 3. How did we come up with that? 1, 2, 1, 2, comma 2.
goes from 26 to 36.
Hmm.
That's that red layer that we're investigating right now. This thing goes from 26 to 36 here.
Hmm.
And in this layer, if we are asked for the value somewhere in this column, it will be roughly equal to 26 plus the row ID. So this 26 is here. 2 rows later here, we would have 28. Or maybe, let's say, 5 rows later, we would have 31 plus 5 rows. Then inside of here, I can instead say that I have 36 here.
So this is 1. This is decreasing here. This is increasing. This is decreasing. Okay. So if column is even, so yeah, the column is 1, 2, 3, 4, 5. No, if the column is odd, we find the number, which is 5 square, which is 25, and then just decrement it by the number of rows. If it's even, 2, 3, 6.
At the beginning of the row. If I want to go, let's say, 3 columns to the right, then what value I will have here? 33. I can explain it again using maybe this layer, one of the previous ones. I start from value of 10. if I want to go 3 rows down, I will have 10 plus 3, 13. I will end
But that is for even
with value
case. 1 over 2 okay.
16. If I instead am interested in the value 2 cells to the right, so 2 columns to the right, 16 minus 2, 14. So roughly the logic, not complete yet, is if we are in nth layer, then if we are maybe in its column part, so this or vertical part, this one, column slash vertical part, the value is equal to, let me see, this is in nth layer, things go from n minus 1 squared plus 1 to n squared. And now we need to add the row, because in this column, in this column, like from 10 to 13, you need to add a row, minus 1, because rows are numbered from 1. Row equal to 1 shouldn't be increased by anything, row equal to 2 should be increased by 1, and so on. Now, in its equal to 1 shouldn't be increased by anything, row equal to 2 should be increased by 1, and so on. Now, in its row slash horizontal part, value equals n squared minus the column part. Like 16 is at the beginning, and as you move with column to the right, you need to decrease. There are some remaining parts here, because we need to detect in which layer we are. We need to detect if we are in this part or this one. And actually, every second layer goes in different direction, right? So this layer goes like that, versus the next layer will start from here and go like this.
Yes.
Which can cause us to have some extra ifs, but I'm going to avoid it. Can this be a DP problem? No. It's not a DP problem. Basically, almost never you will get a DP problem if constraints are so big. If values are up to 1 billion, it couldn't possibly be a DP problem where this is a dimension. You would be out of time and memory. So first, detect the layer, and that's the easy part. For example, so what is this cell? This cell has coordinates of row is 3, column is 6, and we are in the 6th layer. The maximum of row and column is the layer always. So this cell has coordinates of row is 3, column is 6, and we are in the 6th layer. The maximum of row and column is the layer always. So in infinite grid, if you are here, let's say, and your coordinates are 10, 3, then it means that you're in the layer number 10 in this layer. Alternative way to think about it is that if there is a chess king, like chess king, then the number or ID of a layer is equal to the number of moves that it takes a chess king to get somewhere. And that formula is indeed maximum of xy, or row, column. And it even has a name of max metric, or topology. I will look it up in a moment. I think even if we Google for it, maximum metric. Oh, metric is spelled like that, sorry. Metric. This is the name of it.
Should have checked the skills.
Maximum metric. Oh, metric is spelled like that, sorry. Metric. So this is even related to some stuff in chess. Anyway, this is the layer, so let's call it is equal max of row column. Now we need to detect if we are in the vertical part or the horizontal part, and that's assuming that layer goes this way. The cells here, those are cells where column is equal to 10, column is equal to the layer ID, and the cells here are those where row is equal to the layer. So if column is equal to the layer, we are in this vertical part. Also, let me copy this. If column is equal to layer, then this is vertical part.
Okay.
And the answer is equal to this. This is n minus 1 times n minus 1 plus 1 plus row minus 1. This can overflow. Also, what is n? It's layer, I'm guessing. So pass to long. Else, and now I expect now the row to be the layer, and I can even assert that. Assert is a helper check, where if this is not true, I will see this with an error message, and I can think more about what happened here and how. And then here output this. N squared.
What if we are at 2, 2, 1, 2, 1, 2. We go for the layer. 2 is even in square. Hmm, 9 in square. This is 1 plus 1 1 plus 1, which is 2, plus 2 minus 1, which is 3. Okay, but what if we are here? 3, 2. We are in the vertical layer. Here we have n minus 1 square. 3. So 4 plus 1 is 5. 5 plus 2 is
I think, but I'm not 100% sure, that this will work for every second layer. Those that have the direction, like in my drawing. 6, 1, 15. Well, 2 values out of 3 are good, so this gives me hope. And finally, in every second layer, what happens is actually we start from here, and values increase this way.
3.
And I could do a separate check for there. I could do if layer modulo 2 equals 0, then do something, else do the opposite. But that's a lot of work. Instead, I'm going to flip something. Those two directions, this one versus this one, is symmetrical if we think about the grid reflected with respect to this diagonal. And what this means is I can rotate or flip, not rotate, flip or mirror the grid, and you do it simply by swapping row and column. So let's see. In my layer number 2, this direction is correct, but in layer number 3, I want the opposite direction. So if layer is equal to 3 or 5 or 7, I'm going to swap two values. And I'm going to do it here. If layer modulo 2 is equal to 1, swap row and column. This basically mirrors the grid. And now I have 8, 1, 15. I will summarize the solution after submitting the code. And one more thing. I actually don't like this problem. I think that it's a very ugly competitive programming problem or algorithmic problem. It's about ifs, some kind of simple math. If you feel overwhelmed by something like this, it's perfectly fine. And I would even say that among the introductory problems, you can skip this one if you really hate it, because you still can solve way harder algorithmic problems possible. This is just a specific category. Now, to summarize the solution, let's, in our infinite grid, where we have spiral that goes like this, we are given a cell with some coordinates row, comma, column, and we need to know what value is there, or in this order of the spiral when this is visited.
Okay, I think I need to eat some food. It's exactly 2 p.m. I need to rest. I need to eat some food. And then we'll see. I'll continue solving these problems, but first I need to eat some food. Okay. Wow, I was muted the entire time. Anyways, I didn't speak much, I guess. Let's check. Okay. Smash. 2531. When did I mute?
1, 1.
Like 2 or 4. Anyways, it's good.
I also you
Size. And if we are going here, I can. Yes.
the problem.
But then for 2,
Geometric is spelled.
this is 1 plus 1.
If you feel over,
Okay. Oh, okay. So the mic slash shocks is generalized. Huh? This one. Okay. Hmm. We are live again. Let's see. I'm just setting up everything, opening up VS Code and the website, CSES website. Huh. Hmm. Let's go. Oh, my camera is not turned on. Hmm. Okay. A number spiral is an infinite grid whose upper left square has number 1. Here are the first 5 layers of the spiral. Okay. The task is to find out the number in row Y and column X. The first input line contains an integer case, so we have number of test cases. First, let's parse this question. Okay, public class scanner is equal to new scanner string again. Okay, int equal to sc dot next int while t minus minus greater than 0. Hmm, will pass this solve function. Now, what does this solve function do? Like void solve. Do I need static? Okay. After this, there are three lines, each containing integers y and x. Int row r equal to, let's just write row equal to c dot next int column equal to c dot next int. Oh, so I need to declare this here as well. Do c dot close. Okay. Now we know that if we first need to calculate or figure out which uh level are we in, right? So, and this will be long. This will be long. What? Next long. Okay. Ah, now long level equal to math dot max of row comma column. Hmm. How does he handle this? Hmm.
I'm going to first detect in which layer 1, 2, 3, 4,
This is layer.
or in which layer this square is. 6, comma 13, just like from 5 to 9, so from 4
Hmm.
plus 1 to 9. Then similarly here, values will go from 12 squared plus 1 to 13 squared.
Yeah. If it's in column, if layer equal to column, then we print this out. Uh, column, no, which is layer into layer -1 into layer -1 plus 1 n square n minus 1. This is n minus 1 the whole square plus 1. Yes. Else, if our layer is equal to row, then enter this block. And what do we do? We simply return, oh no, here we do need to add, do we add ten here? Hmm. If we move down, we move down. So row plus row and this minus. Okay. So 1, 2, 4. Okay. And if layer equal to row, then what do we do? We just n square it and then decrement the value. Oh, no, here we yeah, here we increment. Here we decrement the value those many amount of times. Okay. So this is layer oh, layer 2 into layer plus not plus minus columns, but here there will be +1 or -1. If I'm at 2 comma let's see, 2 sorry, 1 2 3 4 comma 2. Okay, so column -1. Wait, now this will be in a bracket. Hmm. If if row is even, then just swap, right? And oh wait, long just to be safe. Temp equal to row, row equal to column, column equal to temp. Why is this not running? Fourth row 4. What? Okay. Why did this fail? 4 comma 2. 4 is even there. So swap. If the layer is even, then we swap the logic. Or then we swap, yeah, the logic or the variables. Okay. Not when the row is even. Layer. Hmm. This should work. If layer equals to column n minus 1 square plus 1 plus row minus 1. And if layer equal to row n square minus column minus 1. Yeah, that's what I have done here. And why is this wrong? What is the difference between my code and this? Oh, no, it use layer to trigger swap. But, okay, what is this layer? This is the fifth layer. Oh, no, this is the fourth layer. Okay, so we are calculating for the fourth layer. Okay, so this should have been even. Yes, that makes sense. Yes. Back, submit, choose file. And of course we get it clearly. Uh, no short, it's because of buffer reader. Throws exception. Static buffer reader. PR equal to new buffer reader. Si- hmm, what was that? Input stream reader system dot in. Is it new? Oh, br dot field line and then we do an integer dot parse int. Oh, we don't need a closing statement. Now, how do I write this? Fix the br input. Hmm. This is so unnecessary. Should I just switch to CPP? What is this? This is so stupid. This is so done. Okay. Oh, it asks us to count for k 1, 2 till n the number of ways two knights can be placed on a k. On a k cross k chessboard so that they do not attack each other. The only input line contains an integer n. Okay, print n integers, the results. Hmm.
And now I have 8, 1. Your task is to count for every category. Another math kind of problem.
Hmm.
I'm not a big fan of something like this, but count the number of weights 2 knights can be placed on so that they do not attack each other. Your task is to count for every... No test cases. Your task is to count... Well, sadly, another math kind of problem. I'm not a big fan of something like this, but count the number of weights 2 knights can be placed on a chessboard so that they do not attack each other. So, for example, if n is equal to 4, so we deal with a chessboard of size 4 by 4. Let me draw a knight. Okay, let's say this is a knight. If, for example, you place this here and there, this is not a valid placement because they attack each other. Yeah, it's a snake. So this is what we should not count. But we could place it, for example, here, and now I placed 2 knights, and they do not attack each other. We want to count the number of ways to do those placements. Now, when I place a knight somewhere, most of the placements for the other knight are valid. They do not attack each other. So I'm going to do a very standard trick. I'm going to actually count invalid placements. So I will count this placement as 1, I will count this placement as 1. And my logic will be that...
Okay, just minus those places.
Answer is all ways, maybe let's say x minus y, where x is number of ways to place 2 knights on the chessboard, and I don't care about attacking each other. Y is equal number of ways to place 2 knights, so they would attack each other. And now the task will be much easier because I just count very few possible placements. What is number of ways to place 2 knights on the chessboard? Well, chessboard here has 16 cells. 16 is the number of ways where I can place the first knight, times 15 is the number of ways where I can put the second knight.
Yes.
And I need to divide it by 2 because if I place first one here, second there, it's the same as placing second here and first there. Alternatively, if you know math, this is 16 choose 2. That's the number of good ways. Numbers are number of all the ways. What remains is computing this. But already I will put this into code. I need to do it. Let's say that we read max n, and now for every n, from 1 to max n, the chessboard size is n squared, and then number of all the ways to place 2 knights is
Size into
size times size minus 1 over 2.
Well,
Use long, otherwise overflow. Long, bad ways is equal to something. Those are ways, so they would attack each other. And then print all ways minus bad ways. What remains is to solve the problem.
The bad ways.
So to do the hard part. If I place a first knight in the corner, there are 2 possible placements of the second knight, so they would attack each other. If I place a first knight here, then second can be placed here, there, or there, so that they would attack each other. If it's, let's say, first knight is here, then I have even more ways, especially for big chessboard, for the second knight to attack this one. Alternatively, we can think about it this way. If I place one knight here, how many cells are attacked by this knight? Well, 2, this one and this one, and I will write this down, 2. For this cell, how many cells are attacked?
So, okay.
3. For this one, 3. For this one, 2, symmetrically. For this one, 3. For every cell I'm writing down, if I place the first knight here, how many places are there for the second knight so that they would attack each other? For this place, it's 1, 2, 3, 4, and that's it, I think. 4. In a big chessboard, if you look at arbitrary cell not close to the boundary, then you will have, I think, 8 possible attacks. So for arbitrary cell in the middle, I would write 8. Only close to the boundary, something interesting happens. For this cell, it's 4. And I think the general pattern is like that. Maybe I want to do it in the editor. I think that for big enough chessboard, if I write down how many cells are attacked by every position, it's 2, then 3, then a lot of 4s, then 3, 2. In second row, it will be bigger. For this one, it's 4. For this one, 6. 6? You have all the 8 attacks, except for the ones that go by 2 up. Then a lot of 6s. 4, 3. The reason why I'm doing all of this logic and not just implementing where I try all directions is that I cannot afford very bad time complexity. Size of the board is O of n squared. Of n squared, and that's a lot already. 10,000 squared is 100 million operations, and computer can do that in 1 second, but you need to consider actually all values of n from 1 to the given value. If n times from 1 to n, you add n squared to the time complexity, you get O of n cubic total. This would be time complexity of, for every n up to 10,000, iterating the full chessboard. We cannot afford that. So I'm going to here write down some values in order to use formulas to add this up quickly. This symmetrically is 4 just like here, this one is 6 just like here, and then everything inside is 8. Now this I think gets repeated a lot. And then symmetrically we have this, and symmetrically we have this. I don't know if this is a square, but for every cell I wrote down the number of cells attacked by this position, if the first knight is here. And I need to add this up. So what I have for big enough n, what I have is this inside square of size n minus 4 by n minus 4. I'm going to make n into a long. Yeah, just for convenience. Okay, so this is n minus 4 times n minus 4 times 8. This is this inside square. Then how many 6s there are? Maybe I will do it this way. Start with 0 and bad ways plus equal. 8 appears that many times. Then 6 appears some number of times. 4 appears some number of times. 3 appears some number of times. 2 appears some number of times. 6 appears, well, here in the second row, it appears n minus 4 times, and that happens for... So on 4 sides, here, here, here. So this is n minus 4 times 4. What about the value 4? N minus 4 times plus 1, so n minus 3 times, and that's repeated on every side.
Which is equal to
What I'm doing is it's not really programming, it's math.
n minus 3. Okay.
N minus 4 here, so this is n minus 4 times 4. What about the value 4? N minus 4 times plus 1, so n minus 3 times, and that's repeated on every side. What I'm doing is it's not really programming, it's math. It reminds me of math competitions in high school. The number 3 appears 8 times because it's just close to the corners. 2 appears only on the corners themselves. And the second, fingers crossed about small values, 0. Here multiplied by a coincidence. It's magic that it a bit because it's just a single. That's, and apparently they cancel multiplied by itself. It is positive, but I want to say negative. Negative multiplied by itself. It is positive, but it shouldn't be. This is negative, and apparently they cancel out. Whoa. This value is negative, multiplied by itself, it is positive, but it shouldn't be. This is negative, and apparently they cancel out. Whoa. That's interesting. Still, we solved the problem in time complexity O of n, because it's just a single for loop inside of its formulas. And it's up to 10,000, so possibly you could afford something a little bit slower. I will also write here, it's coincidence. It's magic that it works for n smaller equal 3. It shouldn't, because some values here are negative. Maybe there is some way, using combinatorics, to explain that I kind of treat outside cells as existing just with values -1, something like that. The dog changed position. Twice negative is positive, but here it's more magical than that. I'm really surprised. All right, so 290 is solved. Again, not a great problem, but it's also something you need to be able to do for competitive programming. Let's move on, 2 sets. Another constructive problem, I believe. Test cases? No.
Your task is to divide the numbers 1, 2 till n into 2 sets of equal sum. Hmm. The only input is this, in case if the division is possible. I know otherwise. After this, if the division is possible, print an example of how to create the sets. First, print the number of elements in the first set, followed by the elements themselves in separate line, and then print the second set in similar way. Okay, for 7, yes. stack division is possible, print an example of how to create the site. Okay, this is the size, and then okay, the numbers. One, two, four, seven. This is 14. And this is also 9 plus 14. So obviously, the first step is to sum up till n. We have a math formula to get the value n of an operation. Sum up to n numbers, which is n into n minus 1 or plus 1. I don't remember. Divide by 2, right? Formula to calculate sum up to n numbers. Okay, it's n plus 1. If it is even, we can break it down into two sets. If not, we cannot. Okay. So the actual problem is how do we divide it equal uh into two numbers into two sets which has the same number, which has the same sum. But it just should have. Okay. Okay. So how do I divide this number into equal sets. So we have this number 24, right? We have n equal to 7. So sum is equal to 7 into 8 divided by 2, 56 by 2, which is equal to 24. So we have 24 here. Oh, wait, it's 28. Okay, 28. So we have 28 here. How do I divide this into two sets such that their sum is equal? So if we divide this, we have 14. We have 14. 28 divided by 2 is 14. Okay. So the problem is, how do I divide 14 in such ways that set 1 contains distinct, set 1 and set 2 combined contains distinct numbers? Hmm. We know that 28 is an even number. That's why we can divide it into two sets. So we know that 14 will always be an even number. So what if I divide this by 2? So if I just find a way, okay, 2, if I divide 14 by 2, I get 2 plus 7 plus, so this is equal to 9. What is 9 minus 14? 14 minus 9 is 5 plus 5. Hmm. Okay, so I have 5 here. Now another way of writing this can be just take all the numbers that are not present in set 1. Okay, so we just need to find a way to create a set and create a set where this is true, where set 1 contains 2 and 7 and 14, which is this number, minus 2 plus 7, which is 9. So 14 minus 9 is 5. And then now we have set 1, we need to create set 2. How can we create a set 2? Just iterate over the set 1 and check for number that are not in the range of 7 but it is in here in set 1. So we have 1, we already have 2, so plus 3, we don't have 4, we already have 5, then 6. So 1 plus 3, 4, 4 plus 4, 8, 8 plus 6 is 14. But there is a problem. What if I have 14? Okay, great. But what if 14 divided by 2 or some number divided by 2 gives us another number which is greater than 7? Then what do we do? then we need to divide that number into more subparts until we come inside this range. Hmm. This is a big problem. Let's see.
Your task is to divide the numbers 1 to n into two sets of equal sum. I don't need to write this down, but this is a constructive problem where there might be I don't need to write this down, but this is a constructive problem where there might be multiple solutions. For input 7, apparently values from 1 to 7 can be split into two groups with equal sum. How can we do it? My first thought would be to maybe say that 1 plus 7 is equal to 2 plus 6. So into the first set, I can put values 1, 7. Into the second set, I can put values 2, 6. But it will not work after that, because 3 plus 5 cannot be paired up against something else. Okay, another idea. If I start combining going from left to right, or I start splitting, so for 1, 2, 3, 4, I decide how I split them, with bigger numbers, it will be harder to allocate them. So what about going from biggest values? I will start splitting kind of evenly from big values, always adding 5 to somewhere, and when I get to small values, thanks to the fact that they are small, it is easier for me to assign them, and they will not overshoot the sum of values inside of this set. So I think the simplest possible logic is add a value to the set with smaller sum of values. 6 plus 5, now this is 11. Then we have a 4, insert anywhere. Sorry, insert here because this is smaller. Now 11 and 11, so now the next value 3, insert anywhere. Then this is bigger, so insert a 2 here. Then this is still bigger, so insert the 1 here. Is this correct? Does it always work? To be honest, I don't know. I want to try another n. For that, I also can discuss when the answer is certainly no, and that's when the sum of values is odd. If sum of values is even, maybe we can split into two sets with the same sum. If the sum of all the values is odd, values from 1 to n, we certainly cannot split. So then the answer is for sure no. I want to choose another n. Let's say n equals 8. The sum of values from 1 to 8, that's 8 times 9 over 2, which is 36, so it's even. And let's see if my logic works. 8 I assign anywhere. 7 then I assign to the other set. 6 goes to the set with smaller sum, so here. 5 will go there. You can notice that always the first 4 values are assigned like this, and always there is equality. This actually, I think, is a part of another solution. 13 and 13, assign the 4 anywhere. Then put 3 here, put 2 here, put 1 here, and we have the same sum. So I think we can code it and see what happens. During a competition, you should usually understand if your solution is correct before implementing. That being said, for problems that are easy enough to implement, it's also a valid strategy to implement, if it takes at most 5 minutes, and see what happens when you try tests by hand. So read n, create a and b, maybe lowercase ab, also maintain the sums, a and b, long, to avoid overflows. For every value from n down,
Should I code this solution in CPK as well? Let's see. Then okay. Hmm. N. Wait. Are the numbers big? Yes, it can be big. Long n equal to SC dot next long, obviously. Mm, let's see. Long sum equal to n into n plus 1 the whole divided by 2. This is the sum. What do we do now? If sum modulo 2 equal to 0, then we perform certain operations. Else, just print no. Okay. If sum modulo 2 is 0, which means it's even, this is just boils down to implementation. How can I implement this? First, I need to create an array list integer array1, array2. Okay. For int I equal to 1, I is less than equal to n I plus plus. Or we can call this digit. Okay. What does the problem say? Hmm. If calculate first of all, let's int sum1 equal to 0, sum2 equal to 0. If sum1 is less than equal to sum2, just add sum plus equal to digit and array1 dot add this digit, right? Hmm. Then else, which means if sum2 is bigger than sum1, sum2 plus equal to digit. Why did this not give me an error? Array2 dot add digit. Hmm. That's it. Then at the end, we just write a for loop. Uh, we print the size of this array1. Now int I, okay, then 1. long length 1 long length 1 equal to this long length 2 equal to this length 1 for entire equal to 1 and I less than length 1. Oh no, I plus plus. We just print out array1 dot get I. Then similarly, this is length 2, array 2, and we should be good. Then, wow. Oh, we also need to print. Yes. Why did this number repeat? Oh, okay. I need to add a next line. Basically, just need to format this. Well, ah, this is this. Just add the next line. And we should be good. Yes, 4. Yeah, 1 plus 3 is 4. This is 9. No. Oh no. We move from the bigger digit to the smaller digit. Yes. Oh, this is this should be long. What? Oh, long. Ah, sum tool is equal to digit. Array two.
downwards.
Oh no. Okay. Okay, so this is 7 plus 4. 7 plus 7 is 14. And 3 plus 5 is 8. Plus 6 is 14. Okay, so this is correct. Hopefully this doesn't give me a TLE. Of course. I want main and set. Um, this is so dumb. No, no. The problem is, do I just start it like this into main? You do need this hashtag include std io believe. Oh, with slash c plus plus dot h std c plus plus std c plus plus using namespace std. Why is this giving me an error?
If A greater than B, so B is the smaller set, then B push back X, B plus equal X. I maintain the sum because that's efficient, and every new element I will insert after checking a single if. What if you didn't maintain that, and every time in your vectors you would compute the sum of existing elements, that would be in total n squared, you would get time limit exceeded. Now that I think about all of this, I made a mistake at the beginning of the stream not to recommend something. This CSES problem list, I should have done proper introduction to this. It goes well together with a free PDF out there called Competitive Programmer Handbook, which is this. Not that. So there is a book, which is here. It's written by the same guy who created CSES problem set. And in first chapters, you will get explanation of input-output, time complexity, and often this book talks about problems that are here. Okay, back to solving the task. Now, at the end, if A is equal to B, then print yes, because that's what they told us to print. And then we need to output the two sets. They said that we need to output the size of the first set, then its values, size of the second set, and its values. Else, output no. Let's try for a few inputs. 7. Yes, 0, 0. I guess I didn't finish my code. Else, insert to A.
Okay, with slash std c++ dot h path.
Hello. S- So the problem we are discussing currently is that the Visual Studio Code cannot see that this file is over here. The IntelliSense cannot identify this file, but you can see that IntelliSense can identify the IO stream file. So what the problem over here is the bits slash std++.h file is not a standard file, so it is not included to the location where all the other header files or the standard files are located for the Visual Studio Code. However, we have already installed MingW. I hope that you have already used MingW. So what we'll do is that we'll copy a bits folder from the MingW to a location where the Visual Studio Code can find it. So I will go to the location where my MingW is there. So I'll open program.
Hello everyone, this is Adeep, and if you are watching this video, then you are probably getting this error while trying to use beats/std++ in your C++ program. So if you try to compile a program, you will get this error. That is because the beats/std++.h header file is not included by default in macOS. So we are gonna fix it in this video, so follow along. First of all, go over to the description, and there is a command given in the description. Go ahead and copy that. Now go to your Visual Studio Code, go to Terminal, and click on New Terminal. Now paste the command that you have copied. Here you will see 5 locations. Click on the command key and click on the middle location. Now select it, click on the command key and click on.
What?
Here you will see 5 locations. click on the command key and click on the middle location. Now select any of the folder or files in here. Right click and click on Reveal in Finder. Now go here, create a new folder. You will have to type in your password. Now rename this folder to bits. Again type in your password. Now copy any of the header files from here and paste it in here. Now open up this file using Visual Studio Code. This might ask you for permissions, so give it the permission if that asks. Here select everything and delete that. Now go to the description and there will be a link to GitHub. Go over here, you will find its beats stdc++.h. Copy everything in here. Until #endif, copy it, go back to Visual Studio Code, paste it in here. Now save it, close this, go back to your Finder. Now rename it to stdc++.h. After renaming it, go back. Now copy the beats folder that you have made and now close Finder. Now go back to the terminal, click Command and click on the first location. Now select any file here, right click and click Reveal in Finder. Now paste the beats file here. Type in your password. Now close it, go back to that terminal, click on Command and click on the second location. Click any file here, click on Reveal in Folder. Here paste the beats folder that you have copied. Type in your password. Close the Finder, close this tab, go back to the terminal, click on Command and click on the fourth location. Click any file here and click on Reveal in Finder. Close Finder, close this tab. Now close the terminal. Now if you run your Visual Studio Code, the error will be gone and you will be able to run your program. Visual Studio Code, the error will be. Click on the command key and click on the middle location. Click on the command key and click on the from. Now open up this file using Visual Studio Code. In any of the header files,
Mhm.
Now open up this file, it asks you for permissions. Now go to the discrete list, copy it, go back to Visual Studio Code, paste it in here. Now save it, close this, go back to your Finder. Now rename it to stdc++.h. After renaming it, go back. Now copy the bits folder that you have made, and now close Finder. Now go back to the terminal, click Command, and click on the first location. Now select any file here, right click and click Reveal in Finder. Now paste the bits file here. Type in now paste on command and click on the fourth location folder. Here now click on command and click on the second location. Click any folder and click on the fourth location. Close the Finder, close this tab, go back to the terminal, click on command and click on the fourth location. Click any file here and click on Reveal in Finder. Now paste the bits folder here, type in your password, close Finder, close this tab. Now close the terminal. Now if you run your Visual Studio Code, the error will click on and you will be able to
Hmm. So my tool chain is installed. Configure code runner to use clang plus plus instead of clang. This is when you can put this like this. Hmm. Hmm. Mm. Oh, okay. Mm. Ah, anyways. Okay. Just make make just make
After 8, 1, I would call what I did a greedy solution. But it was very important that we go from big values to small. The other way around, it would not work because often we would be stuck with big values. And thanks to me going from big to small values, when I'm left with small values, they will perfectly fit when possible. We don't have sudden jumps of the sum. I think we could formally prove that with some invariant, that after considering values from n down to some kind of x, the sum between one set and the other set differs by at most x. We can prove that, but if we have proper parity, then it means the sum after x minus 1, the sum usually will decrease, but we can prove that the sum will be now at most x minus 1. After the last element, which is 1, the sum will be different by at most 1, but if we have proper parity, and figures is also important skill in competitive programming, sometimes actually thinking about them, sometimes just having intuition, this is also important skill in competitive programming. But guessing a solution is also a skill. Now, to a solution that it's more clear that it works, we can observe what I said, that the first 4 elements always have the same sum if you arrange them like that. And instead of having this greedy solution, what I could also do is always assign n to the first set, then n minus 1, n minus 2 to the second set, n minus 3 to the first set. We can observe that after assigning 4 elements, the sum of both sets is the same, twice n minus 3. So then I can repeat this process, n minus 4, n minus 5, n minus 6, n minus 7. And again, the sum is the same. So always 4 consecutive values can be split into 2 sets with the same sum. And you only need to think what should happen at the very end with the last 3 elements or less. And if you have 3 remaining elements, 3 to 1, you can split them, 3 versus 2 plus 1. If you have 0 remaining elements, that also works. If you have 1 or 2 remaining elements, you cannot split them. But then you can see that the parity doesn't work, so obviously you cannot do it. I would say that my solution, it's maybe easier to guess, but it's harder to prove the correctness, versus this solution with groups of 4, it's slightly harder to implement, but it's easier to understand why it works, why it's correct. So let's say homework for you, if you want, implement groups of 4, where you, starting from n, always take 4 consecutive elements and you split them according to this pattern, and you do some if, depending on how many numbers are remaining at the end. For example, values 3 to 1 might remain. Okay, the comments maybe I will put to the end. Again, all the codes will be in the GitHub repository. Yes, the greedy algorithm will indeed create groups of 4, but it's not clear after looking at the code. So yes, CSES is good if you want to, for example, learn basic graph algorithms. Introductory problems, but there are other CSES is indeed good for learning concepts, maybe not introductory problems, but there are other topics like DP or graphs. So yes, CSES is good if you want to, for example, learn basic graph algorithms.
about. We'll check this. What is this? Your task is for a number of bit strings of length n. For example, if n equal to 3, the correct answer is 8 because the possible bit string. Hmm. Hmm. Okay, so this is 2 to the power n. but we need to mod it because the values can be very big.
And indeed, here, what you can do too, or for mine is the
So
best, it's
how
just
do
one
you
of
do that?
solutions. What
Because the solution is simple, but the problem is the number will get way too big because 2 power n, because this solution is 2 power n, and long, even long, uh no, we need to mod it, so it should suffice under int, right? Mm. But how do we do that? We can just multiply by 2 and then just mod it by this value 10 power 9 plus 7. So that plus um let's do this first. Standard is equal to new standard system in c dot close. Do we have a single integer? Right. Okay, now what do we want to do? For int I equal to hmm, for I equal to 0, 2 power 3 is 8. So this will be 1. And I is less than equal to n I plus plus. What do we do? What we do is we have int result equal to 0. Oops. Result plus no, result equal to result into n into 2 mod mod int mod equal to 1 2 3 4 5 6 7 8 9. So just print the result, but this will give us TLE. Hmm. Result is 1 in the beginning. Yes. Of course, this passes, but for larger values, like for example, how do new test case 1000. Oh, 2 power 1000. What is 2 power 1000? Mod 10 power 29 plus Okay, so this is correct. Okay. 1, 2, 3, 4, 5, 6. Exactly equal to 10 power 2 power this, and then mod. What is the expected output? Okay. Oh my god. It passed. Okay. Yeah, it passed here, of course, but CSES will give us a clearly. Anyways,
Let's move on. Bit strings. Your task is to calculate the number of bit strings of length n. For example, if n is free, then there are 8 of them. Each of them you have 2 ways, then the answer is 2 at power n. And this task isn't really much about the fact about coming up with this formula. It's about using modulo for the first time. This is not really about bits, not really about strings. It's about modulo operation. I have a video about it on YouTube. I will link it now. YouTube Arito modulo operations. Yeah, this. So if this is new to you, then watch that. Modulo. So here I will not go into details. I will just say this. You read n. You want to compute 2 to the power n. So product of those values of the 2's is 1, n times answer multiplied by 2. Now for a moment I will do it incorrectly. At the end you want to output answer modulo the 1,000,007. I will make a variable for that. Apostrophes, which is legal in C++. Now this is incorrect code because it will overflow for big N, even if you use long. So always with modulo operations, when you increase some value, you need to immediately apply the modulo to it, so it wouldn't increase even more. Modulo operation is required in the problem 90% of the time when the answer otherwise would be huge, and we would deal with overflows, also of long. In Python, we can have big numbers, in other languages too, but then they are slow, and you cannot do even addition of 2 big numbers in constant time. So now this is correct code, or I can do answer is twice answer modulo mod. Since you're doing modulo every time, you don't need to do it again at the end. So now if I run this for value 3, I see something. If I run this for big value, well, I should not see negative value for sure. I like adding new line at the end, but it's not necessary. Submit.
let's see if this code passes or not. Wrong answer. What? We are on the strings. Use output here. What? Oh, I didn't save the file. Of course. Great.
O of n, way bigger n. Okay. Expo that I always forget O of n, and there is something called binary expo that I always forget the spelling. Okay. That can do it faster in logarithmic time, but not necessary here, so I'm not going to explain it. This problem can be solved for way bigger n. Not needed here. Trailing zeros. I like this problem actually. If there is somebody, let's say around middle school, who is good at math, then this is a good problem to discuss for efficiency of computer programs. Trailing zeros. This is a good problem to discuss. You're given n up to 1 billion, which is very important, and for the first time I will talk about the number of operations per second a little bit more. calculate the number of zeros at the end of the factorial. So n factorial. 5 factorial, for example, that's 5 times 4, 3, 2, 1, which is 120. So there is a single zero at the end. If instead I computed 17 factorial, it's this, I think. It has 3 zeros at the end. So the answer would be 3. Very rarely, when you see such a problem, the solution is to compute the factorial and then just count zeros directly at the end. It's not about that. If I try to do it, let's try to do it. And read and multiply. This is wrong. I mean, it will work for small enough data. For example, if I use 5, the output is 120. If I use 20, oops, I got some random error, signed integer overflow, and I see a negative value. Because int is not enough. I can try long, but it will work a little bit longer. For 20 it worked. For 30 it doesn't work and again produces some garbage value. It doesn't make sense to apply modulo here, the modulo operation from the previous task, because then the number of zeros at the end would be messed up. Instead, you want to directly count zeros in some way. Oh, one more thing. If you try this in Python, then this for loop, anyway, is at least 1 billion operations. And roughly, let's say, 1 billion operations in a fast programming language, that's maybe 5 seconds. It's a rule of thumb. It depends a lot on the type of operations. But here, we have time limit of 1 second. Even more, in Python, if you try to do this, the overflows do not exist there, basically. Then factorial will keep growing, and it will not anymore be a number that just takes 4 bytes in memory. And CPU cannot handle this number and multiply it by something in one operation. When 20 factorial is already this number, so it's, let's say, a lot of digits, CPU needs to almost iterate those digits and one by one multiply them by this. So when you multiply 17 times 4, it's a single operation for a computer. It's a simplification. But if you multiply this by 4, it needs to basically iterate digits, or chunks of digits. So it's not even billion operations, this. Actually, it needs to, by 17 times 4, it's a single operation for a computer. It's a simplification. But if you multiply this by 4, it needs to basically iterate digits, or chunks of digits. So it's not even billion operations, this. Actually, this is O of n squared total, because the length of the factorial grows up to size n. So every multiplication is O of n, divided by 32, and you do it n times. So this in Python would have this time complexity, even though you have a single for loop. And it will not take 5 seconds, it will take years. Now, to actually solve the problem, you can experiment a little bit and either use calculator or something, you can even use Python, to compute what is 5 factorial, 6 factorial, and so on, and realize when there is an extra zero at the end. For example, 9 factorial will have a single zero at the end, 10 factorial will have 2 zeros at the end. That's because you took 9 factorial and you multiplied by 10. 10 is not the only value that can create a zero at the end, because 1 times 2 plus and this is 120. Why is there a zero? Kind of, because there is a 5 here at the end, but not only that. 5 needs something else. 5 needs to be multiplied by a 2, or something even. 5 times 2 is 10. In this task, it's actually crucial that 10 is equal to 2 times 5. So every 5 in the factorial, or in the factorization, will introduce a new zero, because it will be matched with something even. We have a lot of even values. Basically, number of zeros, if you multiply a lot of values, a1 times a2, a3, and so on, number of trailing zeros is equal number of pairs of 2 and 5 in the factorization, among the things that you multiplied. In particular, if something is here, I don't know, 8, and here 25, still there is a 2 here and a 5 here, so they will create a 0. But actually, this already shows that as a counterexample. But if you code that fact about counting 5s and 2s, you will miss something. Let's code it for a moment and see what happens. I want to get wrong answer. So obtaining values that are even, so obtaining 2s is not really a big deal. 5s are more rare. So roughly, what I will say is that the answer is n over 5. This is number of 5s among values 1 times 2, 3, 4, 5, 6, 7, and so on. Now, if I run that for the input of 20, which is here, the output works. If I run this for something big, we just output it divided by 5. But it will not work. And 25 times 8 was a good counterexample. So let's submit. But it will not work here. The output works. If I run this for something big, run that for the input of 20, which is here, the output works. If I run this for something big, we just output it divided by 5. But it will not work. And 25 times 8 was a good counterexample. So let's submit. Wrong answer. I could scroll down to see what are the tests, but I don't even need that. I can tell you that 25 times 8, we see something divisible by 5, we see something divisible by 2, but actually the result of that is 200. And that's because 25 contains 2 5s inside. It's 5 times 5. So it contributes 2 zeros. So 25 factorial, my code would think that it has a 5, 10, 15, 20, and 25. So my code will say there are 5 numbers divisible by 5, so there will be 5 trailing zeros. Well, 25 contributes 2 trailing zeros. And there are even numbers in between, whatever. There are enough of them to be paired with the 5s. Okay, so every 25 actually contributes 2 5s. And now, because of the value of n, I cannot, or I don't want to iterate those values divided by 25. That's out of operations, though may be feasible. I want to do this. Every multiple of 25, it contributes an extra 0 at the end. If n over 5 is the number of multiples of 5 present in the n factorial, then n over 25 is the number of multiples of 25 that are present. And those add additional plus 1. For example, now, if n is 25, this is 5 plus 1. There is extra 1 because of the 25. Similarly, value 125 multiplied by enough even values, it will contribute 3 zeros at the end, right? Because this is 5 times 5 times 5. So every multiple of 125 contributes an extra 0 at the end. And then there is 6 to the power of 4 and so on. And now, it's a correct solution to here list all the powers of 5. 6 to the power of 4 and so on. And now, it's a correct solution to here list all the powers of 5. But we are programmers, so usually we don't want to do it this way. I can create a for loop. Answer is, I think int would be enough. For every multiple starting from 5, not exceeding n, and multiplying by 5. So here, this iterates 525, 125, and so on. Answer plus equal n over m. At the end, output answer. And I think that here m, if it keeps growing to 1 billion and gets multiplied by 5 again, it can overflow int, so long is needed. Let's see now, 10 run on 20 is 4, but 10 run on this value is this. So instead, before, for this input I got 256 something, but now for this input I got 321 something. Let's submit, and now I accept it. Regarding the question, why do we care about 25? What if there aren't enough 8s? There are a lot of even values, for sure. So I will claim this lemma. Lemma, number of multiples of 5 is smaller than number of multiples of 2. Also, number of multiples of 25 is smaller than number of multiples of 4, and so on. So 25 can get multiplied by a 4. 50 already inside includes a 2. We will easily find way more even values than those multiples of 5s that we're investigating. Did I get accepted? Yes, I did. Let's move on. We solved 10 problems. How many are there? Can I do this from 1 to this? There's 24 in total. So I think I want to get to the half, maybe a little bit over it. And that will be it for today. So around here we will stop. Oh, actually, gray code will be recursion. This will be not. So maybe this will be a good end for today. Next time we will start from recursive problems and we'll move on. Though it needs to be longer string because also it's harder problems.
Yeah. By this value 10 power 9. That's 7. For that class, um, okay, let's solve this problem. Trailing zeros. A good problem for sure. Mouse. I equal to 5 is less than equal to n I into also plus equal to 5. Sorry. Um, is equal to n. Wait, what? cycle just divide by n. Okay, yeah. We are not storing that value. Okay. At the end, just ring cancel. We should be good. One, two, three, this is 4, 5, 6, 7, 8. 5, 3, 2, 1. Nine, 8, 9, 8. This. Oh, oh, okay. Wow. see. Let's let's see. Okay. Fine. You have 2 point files containing A and B. Let me see how many problems we have. 2, 3, 4, 5, 6, 7. Mm, on each move, you can either remove one coin from the left pile and 2 coins from the right pile, or 2 coins from the left and 1 coin from the right pile. Your task is to efficiently find out if you can empty both the piles. Hmm. The first input line has integer t. After this, there are t lines, each of which has two integers a and b, the number of coins in the pile. Nice. Just print yes or no. Okay. This is yes. This is no. This is yes. Okay. What I think is, what if, uh, uh, I mean, the sum of a plus b should be divisible by 3, because if we remove 2 coins from here and 1 coin from here, but there will be a case. Mm, No. What if in the left pile I have 7 and in the right I have 2. The 7 plus 2 is divisible by 9, but we cannot perform this operation and figure out whether or not there are we can at the end efficiently empty both the piles, right? Hmm. This is 5. This is 5. This is 3. This is 0. Let's see. 5, 1. Hmm.
will you stream today? Test cases. Let's copy some. You have right. So you can either do I minus equal 1, B minus equal 2, or the other way around. Your task is to efficiently find out if you can empty both the piles. You're given AB. Now again, values are big, up to 1 billion, and there are test cases, so you cannot possibly hope to get accepted by just iterating stuff. It's too slow. If you do this, and you come up with something, let's say greedy, where you say this, well, they are, if A is 0 and B is 0, output yes, else output no. This is a correct solution, I think, correct greedy solution, but it will be too slow.
Yes.
Let's test it here. Yes, no, yes, but if I submit, I will easily get time indexed. So up to 1 billion, so you cannot do that many operations in this, because you should realize that time complexity of this while loop is linear, O of A or O of B. A and B are up to 1 billion, so you cannot do that many operations in 1 second. Even more, there are test cases. So actually the time complexity right now is O of T, number of test cases, multiplied by A or B. So it's way too much. We can even test it locally. I can create an input file with just, let's say, 3 test cases, 1 billion, repeated, then something big, and something big. And I will measure the time of running my program. For a moment, hide my face. Measure this on the file in2. This took half a second on my PC, but it's just 3 test cases, and there can be 100,000 of them. That being said, during a contest, I would never do this for such a slow program, because from time complexity, it's obvious that it's too slow. In a contest, you shouldn't even implement that, because coming up with such a greedy solution, greedy idea, well, it will take billions of operations per test case, multiple test cases, no chance. It's not worth implementing. Okay, so what is the solution? We can... If this was a harder problem, sometimes I would even experiment with such a brute force, and I would try to realize for what pairs of AB the answer is yes, and for what it's not. So if actually you implemented the brute force, then what you can do is the answer yes for 10-10? No. Is it yes for 11-11? No. Is it yes for 12-12? Yes. And experimenting like that, you can start observing patterns. That's one possibility. I will instead explain what it is. If you have experience with math competitions, that sum decreases by 3. And the most basic check we can do then
This is an invariant.
is if the initial sum of the values a plus b is divisible by 3. So maybe the solution is if a plus b modulo 3 is 0, then the answer is yes, else the answer is no. We always take frequency in total, so if we want to get down to 0, we need to start from something divisible by 3. That would explain what I saw a moment ago, when for a equals 10, b equals 10, the answer was no, a equals 11, b equals 11, the answer is no, 12, 12, the answer was yes. That's because 12 plus 12 is 24, and it's divisible by 3. If you implement this, it will not work. Maybe that it doesn't work for something here. Well, it will work here, but it's just a coincidence. Weak sample test. A model 3 is 2, b model 3 is 2. No, I don't think so. Because in particular here, this is an example where both a and b are divisible by 3, so that's possible. But also it's possible that one will be divisible by, that they will not be divisible by 3, and the answer most likely will be yes, because the sum is divisible by 3. Now, it's not always the case, and one skill also in competitive programming is to come up with counterexamples. So now we have this theory or lemma, or hypothesis, that maybe answer is yes if and only if a plus b divisible by 3. And if we try to find a
Nope, because I found a counterexample and couldn't solve it, which is 7,2. It is divisible by 3, but the answer should be no.
For example, keep in mind what operations are possible. Our best chance is to think about some absurd case, absurd test, where this is true, but clearly we cannot achieve 0, 0 from such operations. And such a test is, for example, a is equal to 300, b is equal to 0. If we start from this, we cannot achieve 0, 0, even though the sum is divisible by 3. That's also the case here. That's also the case here, 300 and 3, or 299 and 1. Now, with such counterexample, we can think, what is wrong with this? Why I cannot do it? Because applying those operations, you will run out of b too fast. Then what should the values be so you would not run out of b fast enough? Well, it's actually now important what exactly operations I do. When I decrease a by 2, b I decrease by 1. So I will be able to do this thing. 300 and 150 I can do. Always taking 2 from a, always taking 1 from b. So I can do that. But if b is smaller, like this, or smaller, then I will run out of it before I clear a. And from this, we can get some improvement to our solution, that b cannot be smaller than half of a. So b smaller than half of a, bad. No. It's better not to use division, especially if you don't know divisibility, so I prefer to say if a greater than twice b, then no. Because if a is, let's say, 600 and b is 150, I cannot achieve 0, 0 by taking 2 coins from here and 1 from there. Of course, symmetrically, this is the case. And turns out that those conditions are enough to check. So it is enough to say if a plus b modulo 3 is equal to 0, and a smaller equal twice b, and b smaller equal twice a, then yes, else no. I will submit it to make sure that I'm not proving something incorrect. works for the sample test from the statement. Okay. Now, what would a proof look like? Regarding my inequality, what I said earlier is if a greater than twice b, then no. And then the opposite of that is if a smaller or equal twice b, then yes. Hence the changed inequality compared to what you saw in the drawing. Now, regarding a possible proof. In competitive programming, you don't need a proof, but you need a good enough intuition. But also we could actually prove that. And the proof would look like this. It's thinking about either invariant or induction. If you don't know those words or those terms, then it's hard to talk about the proof really, or how to come up with a proof. But you can see how it would go like this. If either of those conditions is not satisfied, then it will always be broken. Always it will be not satisfied. For example, if a is greater than twice b, then we can reason that no matter what operation we do, a will always be too big. If a is bigger than twice that, even if we take 2 coins from it and 1 from b, a will always be bigger than twice b, including the very end, where 0 is supposed to
Right string and number spirals. Number spirals. We have with string great not push. Okay. What else is missing? One, two, three, four, five, six, seven, eight. Increasing array permutations. Okay, we don't have increasing array. Okay. Increasing array. We tag increasing array. Get commit. Increasing array. Get push. Right. Also, I'm going to push two sets as well. Oh my god. Two sets. We add two sets. Commit sets with con public class. Yes, yeah. Okay. Hmm. So we have int for scanner is equal to new scanner system dot in sc dot close int t equals to sc dot next int while p minus minus greater than 0. Let's see. We take inputs long a equal to sc dot next long, same for b. We check if a plus b modulo 3 equals 0 and a is less than equal to b to 2 and b is less than equal to a into 2, then we print yes, yes, else we print no. That's it. It got time limit exceeded. Great. This is a O of 1 solution. How did it get time limit exceeded? Probably because of buffer reader, right? Buffer reader br equal to new buffer reader new input stream reader system dot in integer dot parse int br dot read line. Just copy paste this. Okay, we don't need this anymore. Throws exception. Runtime error. Oh, dot select. So, oh, okay. Yeah, of course. We should be good. Okay. Let's see why two sets failed. Oh yeah, because of this. Hmm. Minus. I'm doubtful this will pass or not, but let's see. Hmm. Wait, I can. Why am I converting this? I can directly do this. Yeah, this should be fine. What is the exception? It's out of bounds. Oh, oh, nice. Yeah, this is correct. This is correct as well. Okay. So I need to change this as well. This is okay. Move on. Move on. Income stream branch system document. Exception. Oh, 4 answers.
To be equal to 0. So same reasoning can be applied to all of them to explain why else the answer is no. But why is the answer yes in this case? For that, we would need to explain how if all of those conditions are satisfied, those conditions or those invariants, exists a move that keeps those conditions. This is the lemma that we need to prove. And then you can say that it's a proof by induction, that if for smaller values AB it works, then for bigger values AB it works. And that move, move obviously, it keeps the divisibility by 3, so that's the easy part. We need to prove something about this part. If those conditions are satisfied, I will not break them. Kind of obviously, what you should do is always take 2 coins from the bigger pile to help those conditions to not break them. For example, if A7, B5, they satisfy the conditions, nothing is twice bigger than the other thing. And
Three hundred 150. If I divide this 150 with 250 by 2. 1 to 5, I will reach hmm, there will be a difference of 25 here. But if we have 400 divided by 200, then 150, we still have a difference of 50. Hmm. But it's 200 and 150. Or matter for 300 divided, it is 150. No, but I want a number which is small. 250, no, 300. Hmm. Twice the speed. Hmm.
Now, if I take two
Okay, so divide by 2, so it should be 150. Hmm. So it's going to
coins
be
from the
the
bigger
like,
pile, so it will be 6 and then 4. Then I need to say that this condition where A is smaller than twice B, it's even, sorry, 5. If A is bigger than B but smaller or equal than twice B, if I take two coins from it, then it's still smaller than 2 times B, because I got A and B to be closer to each other. If A is still greater than B, then this other condition is obvious from there. About it, it's actually a visual interpretation. And it's kind of related to chess knight moves. That is, if you have a grid knight that can move 2 in one direction, draw a lot of, let's say, angle, this row and column as A and B, knight can get to the given cell A, comma B. I'm starting. Interstellar, you're right. I will maybe comment on this before starting Palindrome Reorder. One other solution would be to think about how many operations of both types we can do, and then you can write down some equations. So if you do X operations of one kind and Y operations of the other kind, with equations you can express with equations of one kind and Y operations of the other, the operations, how much they decreased A and B in total, and you will obtain this system of two equations that you can solve. If you do X operations of one kind and Y operations of the other kind, with
hmm. Hmm. So x minus 5 should be equal to a plus b. X minus y operation should be equal to a plus b.
with equations you can express the operations, how much they decreased A and B in total, and you will obtain this system of two equations that you can solve. But I will not discuss it in more detail. I showed the comment, so thank you for this idea. Later somebody watching it can stop, pause the video and analyze it more. Last problem today.
Given a string, your task is to reorder its connect. Okay, try to close this. Given a string, your task is to reorder its letters in such a way that it becomes a palindrome. Okay. The only input line has a string of length n consisting of characters A to Z. And the input line has a string of length n. Okay. Print a palindrome consisting of the characters of the solutions of the original. You may print any value and there is no solution. No solution. Okay. Let me this first go to the classroom. Wait. Huh? Okay. So, palindrome reorder. Given a string, our task is to reorder its letter in such a way that it becomes a palindrome. That is, it reads the same forwards and backwards. The only input line has a string of length n consisting of characters A to Z. Print a palindrome consisting of characters of the original string. You may print any valid solution. If there are no solutions, print the solution. This is 10 to the power 6. Okay. Hmm. Oh, okay. So, what's my approach? Right? That is, mm, it's okay. This compiles is in the repository, I believe. Coin chain, compiles. It's not. Mm, okay, okay. Mm, okay. Mm. So, mm, my approach is to calculate the frequencies. Right? First, check whether this int length equals length. If length is even, we perform certain operations. If length is odd, we perform certain operations. Or this is for even case. Okay, what do we have here? Interval character. You may print any valid solution. Okay, so first, object vector, and then integer. Basically, we are calculating the frequency of each characters. Mm, small, or I less than length I plus plus. If frequency dot put, uh, first we need to get the character where ch equal to s dot char this index. Just put this, then frequency dot put I'll not put the fraction, put our default, put our default, oh, set our default frequency. No, okay. Now we have the frequency of each characters. Check if length is even or odd. If length is even, what do we do? Hmm. Check if for hash for map dot entry register, and this is integer key frequency dot entry set. What do we do here? We check int value. Hmm. Int, it should suffice, int value equal to e dot get value. Okay. If val is not equal to 0, that is if it's odd, if it is odd, we print no, and then break. If we get out of this loop, we need to start printing the palindrome. Okay. Hmm. So yes. Now just build, or you can just directly print for int I equal to 0, I less than length by 2, it is plus s out. No. Frequency. Okay. Okay. Hmm. We create an array, character array. Hmm. We create a character array of this length, then iterate over mm, iterate over our map or map dot entry. This is character integer p frequency dot entry set. This is just a check, right? Hmm. Hmm. We create a boolean. Okay, set it to true. If it's no, we set okay to false. Okay, if it's okay, we can enter this loop, else we'll exit out. Hmm. Now, character key dot get key into value. This this is this loop will at max run 26 times because 26 characters in an alphabet. This for loop hmm, will run at max of n by 2 times because we are filling only half of the array. I equal to 0 is then value divided by 2 I plus this. Now also initialize an index uh, array array of index equal to this character and then id x plus plus. Okay. Now we just copy paste this thing I equal to n minus 1. I is greater than equal to n by 2. N by 2. I minus minus. N is the length. Okay. Hmm. Then what to be find? No, we just store array I n minus no array I equal to array equal to array n minus I minus 1. This can create an issue for the like if length equal to 4, if length equal to 4, half of it I will be at 2. 4 minus 2 is 2 minus 1. Okay, fine. Now just print the array. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, you have to get even. Yes, we have a hmm, why? Why did it say no? Hmm. Like, it's fine. Hmm. Why is this indeed one? This is weird. Let me see. Student. Perfect. Okay. Hmm. Okay. Oh, it should. Okay. Split it. So this is correct. What if I add another A here? And the answer should be no. One, two, three, four, five, six, seven. Yes. If the value is all, print this. Why is it not printing this? Hello. Wow. Is this for loop working? Oh, yeah. A, B. Okay. So we have a number. Okay. Hmm. Because this is an odd number. Makes sense. If the length is R, okay, look, there's a better solution to this.
Palindrome a math problem. That is, it reads the but then B is not the same as A. There's no other B, so we need to get rid of. Then C, the same that they are is C A A A B A A C. It's also a valid string that is a palindrome, and actually here I think also that happened in constructive problems. This is kind of constructive. You may print any valid solution is a very important sentence where there can be many palindromes we could obtain. It doesn't matter which one you other things. You can use YouTube comments later for the problems I'm solving. If you have some other things, you not repeat a lot of stuff. From the both end now. What I did a moment ago is I went from the both endpoints, tried to fix the characters, and that can be a valid solution, but it's very complicated.
Hmm.
Instead, what we should do is we should just think, how can every character, for example, character A,
Are you going to do from the center and then expand it?
at what positions it can be? For example, I can say that characters A as well can take prefix of the string and the suffix, as long as it's the same number of occurrences. So if A appears even number of times,
Okay, I understand. Instead of this, we start from the middle. We start from the middle index. For entire equal to length by 2, a greater than equal to 0. Yeah, I plus plus. Oh, I minus minus. I. Okay. What we do is array of I equal to, no, first, no, this is true. We need this. Value of IDX will be length by 2. This is true. Array of IDX is this, and array of in that is length minus 1 minus IDX is this. And then we can decrement IDX. This will exactly become equal to 0. Mm, Let's a 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 1, 2, 3, and then 2, 6. No, we just need to remove this. Yeah, this is correct as well. See, a 1, 2, 3, 1, 2, 3. Yeah, just remove the print statements. That is like, yeah, and that's it. Hmm. Right. Here we have 1, 2, 3, 1, 2, 3. This loop runs 6 times. 0, 1, 2, 3. I mean 3 times. 0, 1, 2. LDS minus. Let's also turn this. Array of dimensional x. Is this, and we have nothing. So equal to, why is this not going to, oh wait, bad. Yeah, 1, 2, 3, and this. What? Oh, 3 minus 1. Okay. Check. Yeah, we also need yes, of course. Hmm. This does make sense. This is better.
Put half at that, do the same for b. If b appears even, b put here, b put here. What if something appears odd number of times? Then our only hope is to put it at the very middle.
Okay.
For palindrome, middle is the only place that doesn't have a match. For example, a word I is a palindrome where the character Y doesn't have a second Y. Everything else needs to have a pair, so the frequency needs to be even. Which means that if something appears odd number of times, one occurrence you can put in the middle, if n is odd, and for everything else, put it at front and back. For that, I'm going to first count the frequency of stuff to know how many I want to put. So I will not actually swap characters one by one. I will just go through characters from A to Z. If you are doing a lot of interview prep, so lead code, stuff like that, or you use, let's say, Python where it's convenient, very likely you are using dictionary to compute frequency of every character. And when you see character A, you can do frequency of A++. Or when you see character, let's say a variable, this problem, but generally frequency of C++. It would be fine in this problem, but generally maps or dictionaries are slow, while arrays are fast. So already starting from easy problems, I always recommend people to immediately start learning using fast data structures, and the fastest data structure out there is array. You can do it this way, but it's so much faster, like 10 times faster, to do it using array of size 26. So I'm going to make array of size 26. Also, you could type int frec of 26 here. This stands for frequency. It's a frequency array, 26. After reading the string, for every character in the string, frequency of this character plus plus. That's first part. But now characters are actually characters, not numbers, so this wouldn't work. But I can cast character into a number by doing this. This is how you can cast uppercase A into 0, uppercase B into 1. we subtract ASCII values A to Z in whatever. If frequency of C is odd, then if n is even, then already this is a fail, no solution. Return 0 is needed to stop the program completely. It's like terminate, exit 0. Else, at the very beginning, at the very middle, you can put this character. So let's say output or S of n over 2 is equal to this. Skończę za 5 minut. Now, is that right? For n equal to 3, this is 1. Yeah, that works. This is how you can cast a number back to a character. Also, I cannot do this if already some other character took the middle spot. So I'm going to say already middle is equal to false by default, and here or already middle is true. If this already was done, I already took this middle spot, I cannot do it again. So no two characters can be odd, can have odd frequency. Here I take the middle character. And not else, just no matter if this was odd or even, the remaining things, I will do here frequency of C minus minus. So this single odd occurrence I took care of. And what do I do with other things? I split into half. Half is equal frequency divided by 2. So now, what's the... I would normally do this. S of I is equal to S of n minus 1 minus I is equal to this. So this is ith character from the front and from the end. That being said, possibly some stuff is already taken. And I will keep track of it. This is how many characters at front I already used. And for that, I will here add taken plus. If 5 characters at the front I already used, then I cannot use them again. I put at next available position. And this will similarly be minus taken minus I, yeah. Then after that, taken plus equal half. I think this is correct.
Yes.
I'm really not sure. We'll see. And then I will explain some alternative implementation method. 12 palindromes. Okay, works. Now I will change this code a little bit to something that I think is harder to come up with, because here I kept working on my thoughts and eventually they turned into full code. But if you are a little bit smarter, you might remember that palindrome is its first half and second half is basically the same, just backwards. So this code will be way more simplified if we build only one half. So I'm going to change this a little bit, and the half will be an initially empty string. Mark. I will have a separate character for that middle character. Initially, let's say question mark. Okay, so I have this, and I will build using this string. Now, when this, then something happened here. Middle is equal to that. If middle is not question mark, then no solution. Middle changed to that. frequency dot sure. And now what I'm going to do is half plus equal. I want that many times to add character this. And all of that gets erased. What is this line of code in C++? When you type string in brackets, what you provide is the length and then the character to be repeated. For example, if I type 10, comma b, this will be a string with 10 characters b. Here what I did is I'm adding a string with that many characters c. Here's how I built one half of the string. And now I need to print this half. If middle character is not the question mark printed, reverse the half, print it, and new line. That's a very different way of implementation, but I think it's also worth discussing.
So basically, we should use arrays instead of hash maps because it's faster. Okay. Hmm. Char frequency equal to new character 26. Just get first get all the frequencies. I less than length I plus plus calculate the frequencies. Frequency of I minus a ch char ch equal to s dot char at I. Okay. Now for int I equal to 0, I is less than, or rather let's call it ch equal to 0, ch less than 26, ch plus plus. What do we do here? We want a string, so we can use a string builder. S3 equal to new string builder. Int value, that is basically the frequency of this character. Um, hmm, if this is even, hmm, no, if this is odd, what do we do? If the value is odd, we check if the length is even, or if mid is already taken or not. Mid should not be equal to question mark. Mid equal to question mark, right? If this is true, just print no and then return. Else, if it is even, if the frequency of this character is even, what do we do? Hmm. We loop it for this many times and then append the value of ch plus a. But what if now do we have a for loop here? Well, wait. If this is such a thing, else mid is equal to okay. This is inside this, right? Yeah. Mhm. Else mid equal to ch plus a. Why can I not do this in Java? How to do this in Java? Okay, so I was correct. It's just that I have to add some brackets. Okay. Hmm. We change the frequency of this by 1. We replace it by 1 because this is already taken. Now, frequency of ch reduced by 1. This should be here. It doesn't really matter if it's here or here, but uh, technically it should be here. Why? Because we are assigning the mid value here because if this condition becomes true, it will return anyways, right? So yeah, technically we don't even need this else, but for readability and understanding the code, it's better. Okay, now what do we do? Yeah, we just append sb dot append, or we can do this offset and then length. So I do want to append, not the meg, char of ch plus a, how many times? Value by 2 amount of times. Or rather, just many amount of times. Fix the syntax. No. How do I just loop it? Whatever. I have to loop this. Oh, I plus plus. Okay. That's it. String first equal to sb dot to string. String second equal to sb dot to string dot, no, sb dot reverse dot to string. If mid is not equal to question mark, then south first plus mid plus second. Else out first plus second. Okay, that's it. One, two, three. Yes. Hmm. Okay, let's see if this gets accepted or not. Wow, So when we get the right answer, we don't print yes. Only when we get wrong answer, we print no solution. Ah, great. Why did my code fail? Dude, my hands are literally up here. This this input has made uh my computer slow. It's not even entering. Oh no. This should be not this. Why is this here? Oh my god. This should be int. This should be int. Plus, yeah. How did that pass so many test cases? Never build a full Palindrome. But I did. Mhm. How do we fail? How is this normal? 6. So math. What is no? Oh, with that strength math part. Why do we? No. Uh-huh. What? What is it? Wait, I guess because I copy pasted this, now this got truncated. What do you mean by truncated? What do you mean by truncated? Need to close this. Open code forces. Where is code forces? Need to speed run this one. Forces. Okay. I will be back. Just have 2 minutes. Yes. So I am so done right now. Think I will leave. I'll stop the stream now and I'll see you all tomorrow.